In 1912, the Titanic, then the largest ship afloat, was built at the very limits of size and power that the technology of the time allowed. Today, ships many times larger and more powerful are in service across the world. This breakthrough came from an invention by a modest man working from this backyard workshop in suburban Melbourne. Anthony George Malden Michell, or simply George Michell as he preferred to be known, was probably Australia's greatest inventor. While pronounced as Michelle by many in the maritime world, his family pronounced their name as Michell. His brother, John Henry Michell, was one of our most distinguished mathematicians. But this story starts with their parents. In 1854, John Michell, a miner, and Grace Rouse, both of Devonshire, England, joined the gold rush to Victoria and settled at Tarrangower, later to be called Malden. Here they had 3 daughters, and in 1863 a son, John Henry, was born. John Sr. prospered, and his business interests came to include the North Block Quartz Mining Company, of which he was the largest shareholder. The company was a tributor. It did not own a mine, but paid a royalty to the owners of the Eagle Hawk Union Mine for the right to work that mine. That mine eventually became part of the Union Hill Mine, which continues in operation. In 1870, this prosperity allowed John and Grace and their 4 children to sail to England for a 3-year-long visit to family. On the 21st of June of 1870, not long after their arrival in London, George was born. In 1873, the family returned to Malden, where the older children may have attended the Wesleyan Commons School. In 1875, together with 5-year-old George, they were enrolled at the newly opened Malden State School. John Henry displayed exceptional promise in mathematics, and in 1877 he took up a scholarship to study at Wesley College in Melbourne. To be nearby, the family moved to South Yarra, where George was enrolled at the South Yarra State School. John went on to study mathematics at Melbourne University, graduating with a Bachelor of Arts. In 1884, he took up a scholarship for further study at the University of Cambridge in England. To support John through his studies, the family relocated to this house nearby. Meanwhile, George attended the Perth Grammar School, and on graduation, he was awarded all but one of the available academic prizes. He subsequently enrolled at the University of Cambridge, but rather than follow his brother into mathematics, his more practical interests led him to study physics, chemistry and mechanics, plus some classical Greek art. In 1890, at the conclusion of John's studies, the family returned to Melbourne and bought this house in Camberwell. It is said that John Sr.'s commercial interests then included a fruit business. John Henry soon took up a position as lecturer in mathematics at the University of Melbourne. He went on to be appointed Professor of Mathematics and Honorary Research Professor. He retired in 1928 and died in 1940. His paper, The Wave Resistance of a Ship, became a respected reference for the design of large ships. In 1904, he was made a Fellow of the Royal Society. The J.H. Michell Lecture Theatre at the University of Melbourne now stands in his honour. He is also honoured by the Australian Mathematical Society's J.H. Michell Medal. At the same time as John's appointment to the university, George commenced his own studies there in both civil engineering and mining engineering. For a period, he also studied architecture. In 1895, he graduated with first-class honours in both engineering disciplines, and in 1899 received his master's degree in civil engineering. After graduation, he joined in partnership with one of his university teachers, and together they developed and designed a new form of regenerative pulp, which became a staple component in irrigation projects across Australia. Following the death of their father in 1896, bachelors John and George built this house in Camberwell as home for their mother, themselves, and their two spinster sisters, Grace and Amelia. They named the house Mondo. In 1902 and 3, George was employed as an examiner of patents with the Victorian government. However, his need for creativity and innovation led him to form his own engineering practice, specialising in irrigation, water supply and sewerage. Among his innovations was a new type of water meter, which, like the regenerative pump, was a commercial success. His innovations were not limited to the field of hydraulics. In 1904, he published a paper providing tools to minimise the inefficient and expensive over-engineering of structures. From this came the Michell theorem, which later became widely used firstly in aeronautical engineering and then more broadly. His theorem now forms the basis of many computer-based applications for structural engineering design. By reverse engineering, later scholars demonstrated that the Michell theorem was also applicable to structures in the natural world. George's most notable invention came in 1905, when in both England and Australia he took out patents for the Michell tilting pad thrust bearing. Thrust bearings bear the thrust of a rotating shaft, such as a propeller shaft, and transfer that thrust to a solid structure or to a ship's hull. Previously, thrust bearings involved two flat surfaces moving against each other. They were heavy and expensive and were difficult to keep lubricated. The risk of overheating limited the power and speed of propeller shafts and thus the size of ships. The tilting pad thrust bearing allowed ships to be built up to many times the size of the Titanic. Unequivocally, it revolutionised shipbuilding and sea transportation. George's inventiveness did not end there. His roll of patents includes, among many others, journal bearings, the Michell viscometer, a telegraph cipher system and a cipher decoding machine, both used in the First World War, and a hydraulic transmission, which he installed in his own 1912 Buick. In 1916, George was asked to investigate the feasibility of hydroelectric power generation for Victoria. His investigations took him to remote parts in the north of the state. Due to the war, however, decisions on the matter were deferred. Later, Sir John Monash, now head of the State Electricity Commission, convinced the government to favour the burning of brown coal. George believed that Monash's submission contained significant distortions and omissions. By the time George was able to put the hydroelectric case himself, commitments had been made that made it all but impossible for the government to change its mind. At that point, George withdrew from any further involvement in the process. George's position has since been vindicated, with hydroelectric generation now providing many times the amount of electricity originally being considered. It was also during the First World War that George began to design an internal combustion engine that, instead of a conventional crankshaft, used a rotating tilted plate to drive and be driven by pistons. In 1917, he applied for his first patent over the design of the crankless engine. Revolutionary in design, it had numerous applications in transport and industry and was more efficient than the cranked engines of its time. Designs were completed and numerous prototypes developed for petrol and diesel engines for use in road vehicles, compressors, pumps, submarines, torpedoes, boats and even aircraft. Ford and General Motors in the United States considered adopting the engine, deterred only by the retooling costs and the commercial success of their then current engines. Had they done so, the crankless engine may well have become the standard form of automotive engine for most of the past century. However, it met with some success in other fields, including gas compression. It was also being considered by the United States Navy as an aircraft engine when it was overtaken by the development of jet propulsion. George Michell remained in engineering practice for many years and continued to add to his role of inventions and patents. These included adaptations and improvements to bearings and to the crankless engine, as well as a process to prevent nuts and bolts from loosening. He also turned to technical writing, and at the age of 80, he published The Principles of Lubrication. Like his brother John, George maintained a lifelong interest in the natural world. Together at their home, they developed an exceptional garden with many rare exotic trees and plants. In 1912, he bought a farm at North Bunyip in Gippsland and turned much of it into a conservation reserve. In 1934, in recognition of his great contribution in multiple fields of engineering, he was, like his brother, inducted as a Fellow of the Royal Society. In 1938, he received the University of Melbourne's Curnow Medal for Distinguished Engineering Achievement in Australia. 5 years later, he became only the 4th recipient of the James Watt International Gold Medal awarded by the Institution of Mechanical Engineers, London. In the late 1950s, he became frail, and in 1959, he passed away, aged 88. In 1978, the Institution of Engineers Australia named its highest honour the AGM Michell Medal. The Michell Hydrodynamics Laboratory at the University of Melbourne also honours this humble engineer. George's life and contribution have been the subject of books and numerous biographical articles, as well as an entry in the Australian Dictionary of Biography. However, more public recognition has been limited to plaques on the Maldon Primary School and on his former home workshop at Camberwell, and in the naming of the road leading to his former property at Bunyip. George Michell was a quiet, unassuming man, more interested in solving practical problems than in building wealth or social position. He was not, however, without humour or generosity. He made significant contributions to both structural and mechanical engineering, to the irrigation of Australia's farmlands, to national security in time of war, and to hydroelectric power generation. Through the crankless engine, he came close to changing the fundamental design of the motor car. Above all, his tilting pad thrust bearing revolutionised shipping worldwide. Anthony George Maldon Michell has left us all a great legacy.